So this category is exponential functions basic. So a town has a population of 17,000 and grows at 4% every year. What will be the population after 5 years to the nearest whole? Okay, so this time we have to write our own formula. So we have, let's see, P for population is equal to, what letter should we use for the starting amount? I'll use S for starting. I think that makes sense. And then we're going to have 1 plus or minus the R, the rate as a decimal, to the power of T, time. Okay, so this is the formula we're going to be using for this category. And so let's plug it in. P for population is equal to S, the starting rate, so 17,000. And then we have 1, either plus or minus. So plus is going to be for growing things, and minus will be for things that shrink, like radioactive decay. That would be shrinking every single time. A population that's growing, it's going to be growing every time. So we're going to use a plus this time. So if it's increasing, you're going to use a plus. If it is decreasing, you're going to use a minus. In this case, we have a population that is growing, so you want to use a plus sign. Okay, 4% every year, so 4.0%. We are going to take that decimal and move it 1, 2 to the left, so now it's 0.04. This is our R. So then I replaced the R with 0.04, and then now we need the T value. T is going to be 5. So I'm going to type this into our calculator. Now before I do that, are there any questions? So on our calculator, let's clear all that. We have 17,000, and then 1 plus 0.04 to the power of 5. And we want it rounded to the nearest whole number because we are talking about a population. And so that's number of people. You cannot have 0.5 of a person, okay? Otherwise, it's really morbid. Okay, 20,683. So this is our nearest whole number, and this is what we are typing it in as. And let's submit. And let's do another example. And then let me screenshot this. Okay, so remember we're using this formula. Okay, so P, I'm just going to use it for, in this case, the amount of element. I know we're not talking about population anymore, but I already wrote P for the last problem, so P is what we're looking for anyways. So the amount of elements. Okay, an element with mass 970 grams decays by 15.1% per minute. How much of the elements is remaining after 14 minutes to the nearest tenth of a gram? Okay, so S stands for our starting amount, 970. 1, and then plus or minus. We are having exponential decay, which means the element's kind of disappearing. So it's going less and less, it's decreasing. We are going to subtract. So earlier we had a population increase, so we put a plus sign. This time we have a decaying element, so it's shrinking, so we're going to use a minus sign. All right, now R is 15.1%. However, we need to take that decimal and move it 1, 2 to the left, so we get 0.151 as our R. So I'm going to write 0.151. So we have to just turn that percentage into a decimal, and then that's what our R is. Okay, and last but not least, we have T. So what is the amount of time that's passing? 14 minutes. So I'm going to raise it to the power of 14. And so we're going to type this into our calculator. Before I do that, are there any questions? And type it in. Okay, so we have 970, and then 1 minus 0.151 to the power of 14. So I literally just typed in what I said I would type in, and we got 98.057. We are rounding it to the nearest tenth of a gram. That means 1 decimal place. So I'm rounding this to 98.1 because it's technically a 0.05. So the 5 is a big number, so we're going to round the 0 up to a 1. So it's 98.1. Are there any questions? Okay, and then let's do another one. A town has a population of 13,000 and grows at 4.5% each year. What will be the population after 13 years to the nearest whole number? Remember, our formula is this. Okay, so population, P stands for population. It makes sense this time. S is your starting amount, so 13,000. 1 plus or minus, we are growing, so this is going to be a plus. And then our R is 4.5%. But we need to take that decimal and move it 1. 2 to the left becomes 0.045. To the power of t, which is 13 years. So I'm going to type this into our calculator. But before I do, are there any questions? So 13,000 and then, 1 plus 0.045 to the power of 13. Oops. Oh no. Okay, there we go. And we're rounding it to the nearest whole number, so I'm going to put 23,039. So it's a 38.5 at the end. Remember that 5 is a big number, so then you round the 8 up to a 9. So it's 23,039. And then let's look for one more exponential decay problem. Not this. Exponential decay problem. Oh, okay. Here it is. So this one is not necessarily about a bacteria population or elements or anything like that. This is a new car purchased. So let's read it. A new car is purchased for $23,700. The value of the car depreciates, so that means it's decreasing, at 13.5% per year. What will the value of the car be to the nearest cent after 10 years? So remember, it's still the same basic formula. I know P doesn't really stand for, oh, I guess P can stand for price. Doesn't have to stand for population, but no matter what, P is the thing we're looking for. S is our starting amount. So we start off with 23,700. And then 1 plus or minus. So we have a car that's depreciating, which means the value is going to go down. So it's decreasing, so we want to use the minus at 13.5% each year. Okay, let's convert this to its decimal form. We're going to take the decimal and move it 1. 2 to the left becomes 0.135. So I'm going to put that over here in place of the R. And then it's raised to the power of t, so that would be 10 years. So this is what I'm going to type into our calculator. But before I do, are there any questions? Let's type it in. 23,700, 1 minus 0.135 to the power of 10. And we're rounding it to the nearest cent. So that's 2 decimal places. All right. So notice that it's 0.883. The 3 is a small number, so we're going to keep it as 8. So it's 0.88. All right. I'm going to submit that. And let's go to that last category.